Hello, my name is Farzam Uddin and I'm a student of Masters in Computer and Electrical Engineering from Antalya University. Today in this video, my presentation topic is Simulator 5G. 5G new radio users plane simulation model for iNet and OMNET++. In this 5G we have Simulator 5G with new radar user interfaces simulation models for iNet and OMNET. Now let's begin. First we have introduction. As we see, 5G access multi-access edging computing MEC will be the two fundamental foundation of the next technology revolution in mobile networks, smartphones. We have this currently 5G smart cities models like autonomous vehicles, augmented realities, industries 4.0. It will be benefits ultra reliable, high bandwidth. It has low latency connections, 5G and radio access networks will be deployed in this stage with live with existing 4G infrastructure but what we have in before 4G for a long time. But Simu5G is a novel, is a summarized 5G simulation library, has OMNET++ library simulation framework in it, which can be instanted and connect to build up the complex simulation scenarios in this simulator 5G. It is full compatible with iNet library, OMNET++ library for simulation in 5G, which allows to simulate an end-to-end scenarios processes involving the complex TCP and IP networks protocols. We have Simulator 5G simulates 5G communications using heterogeneous G-node space stations, micro, pico, and so on extras DC that may communicate over the external interfaces. Physical transmissions is presented using realistic, customizable channels mode and 3GPP. Compliant protocols layers in this 3GPP standards also allows the resources allocation in both uplink and downlink directions interfaces as well as carrier aggregations. Different numerologies we have. Simulator 5G supports a wide range of user interface, user UE mobility types including vehicle mobility, autonomous controlling, and many more others. Now we have this OMNET module connection, which we have simple 1 module, simple 2 module, 3 connected. It's a compound module. In this we have 2 module. These are the gates and connection between it. Now we have to look in the OMNET simulation framework, the framework of the OMNET++ simulation. OMNET++ can present itself nearly any type of networking, including the wired, wireless, on chips, on sensor, photonic, on so on extras ETCs. Modules which might be basic or complicated are its basic building blocks, model blocks in it. Messages are sent between modules via connections that connect their gates through connections between their gates. It serves as an interface in between two modules. We can see OMNET++ supports the fundamental simulation features, for example, event queuing, random numbers generation, and so on, enabling users to focus on the developing their own simulation models. A model's behavior is written in the object-oriented programming language C++, while its description is expressed in network description net language. Net is a declarative language that makes use of inheritance interfaces between modules. through communication between modules. We can see NAD enables the creation of parametric simulation situations such as rings or trees of varying sizes, complex sizes. The OMNET++ program supports simulation and workflow automation, and INET includes the Internet stack models. Includes Internet stack models, TCP, IP, stack at host from the application to the Mac, multi-edge accessing communication, as well as composite models that may be easily configured. OMNET++ can slow down the flow of simulation time to match the speed of a real time. It can slow the flow of the simulation connection between one module to another of the real time to match the speed. This is only conceivable if simulated time is quicker than actual time. It only can be done when the simulated time is quicker than the actual time what we have, which is development on event density. The INET library allows one to connect a simulation module to a host network interface. In INET library, it allows to connect a simulation modules to the host network interface. And we have related work, what we research, what we get. When it comes to the wireless network modeling, when we see the wireless network modeling, there is a significant difference between physical level and end-to-end simulator level. Link level simulator represents the physical links with high realistic things, but do not often represent layers of the Mac. but don't but not often it doesn't present the layers above the multi-axis routing. End-to-end simulators comprise models of application logic, layer 4, layer 3, layer 2, which we can see in the figure. After that, protocols we have, as well as network equipments that runs those protocols, and they are always discrete event simulators. We identify the standalone simulators from model libraries for simulation frameworks in an orthogonal manner. The latter defines a simulator in which interaction between composing the model is more significant, more reliable than the amount of detail in any individual or one model we get. We are curious about how application level number perform as a result of upper layer designs, and a simulation framework is a piece of software that allows programmers to create their own model libraries. Model libraries, when properly developed, are compatible and usable and hence verified by the frameworks, and they frequently include the pre-installed functionalities such as event handling routines and random number generation. Simulator 5G is an end-to-end simulation model library designed for OMNET and INET platform. Simulator 5G may be used to simulate a multiple cells 5G network capable of transmitting applications traffics at speed up to several MBs. The research community has few additional tools for simulating 5G networks. The Vienna 5G SL simulator is also known physical level simulator that allows one to measure average physical layer performances. Now we have 5G network and 5 the simulator 5G library. 5G cellular network is made up of two components. One RAN, a radio access network, and a core network CN. The RAN is made up of cells that are managed by a single base station. That the data plane. The data plane whereof CN is made up of one or more user plane functions UPFS that connects the RAN to the data network. The GPRS tunneling protocol is used for forwarding in the CN core network GTP. Here we have the architecture of a data plan of 5G cellular network. The figure shows us the RAN is composed of cells under the control of a single base station. 5G base stations are called G nodes base stations, and they represent evolution of 4G base stations, which are called E nodes base stations. UE are attached to a base station, you can see in picture, and can change the serving base station through a handover procedure. Base station communicates with each other via X2 interfaces or a logical connections which normally runs on a wired network. The data plane of the core network consists of one or more user plane functions that provides the interconnection between RAN and a data network. Now we have Simulator 5G library. Simulator 5G is a program that simulates data plane of a 5G new radio RAN radio access network. The present the version does not support signaling or management protocols. All nodes are geolocated GPS on three-dimensional Cartesian plane, allowing inter-node distance to be calculated. Or protocol layers from the physical to the application are included in UE model. The IP and the TCP UDP protocols are also included in this library. Now we have the main modules of Simulator 5G models library. Simulator 5G simulates the data plane of the 5G new radio RAN. Signaling and management protocols are not implemented in the current version, but they can easily added by the interested user. The main element of Simu5G library are NR and G node base station compound modules, which model a UE and a GNB G node base station and NR capabilities. Their internal architecture is shown in the figure. All nodes are geolocated on three-dimensional Cartesian plane, which allows one to measure inter-node distance. For example, to compute the path loss, the UE model includes all protocol layers from the physical to the application layer. It also includes the IP and TCP UDP protocols, as well as vector TCP UDP applications. A GNB compound module, on the other hand, contains protocol up to layer 3 IP. Layer 3 IP. 3 IP. It has two networks interfaces, one for NR implemented in NR NIC GNB module and one for wired connection to the core network. Figure 4 depicts the internal construction of both NICs, which will be detailed in great detail later. For time being, we just need to notice that the NRNCU module contains a dual stack of protocols indicated by LTE and NR prefixes to enable dual connection with both LTE and NR, as seen. You can see in this figure structure of NR NIC modules, where the figure shows us that GNB compound modules includes protocol up to layer 3 IP and has two network interfaces, and NR1 implemented in the NR NIC GNB module, one running the point to point protocol for wired connectivity towards the core network. And it will be described that for the time being we just observe the NR NIC UE module has a dual stack of protocols identified by LTE and NRIC. Otherwise it has one, and dual stack protocol it has, and to allow the dual connectivity with both LTE and NR for the deployment roadmap. In terms of core networks, Simulator 5G provides an implementation of the 5G core's UPF elements. The GTP is implemented by the UPF module for routing IP datagrams between GNBs and the data network. GNB can be linked to the data network through core network. The architecture is known as a standalone SA deployment. It is likely to be used in 5G only deployments. However, it's in ways that in the next years of 5G would be the implemented along 4G and cohabit with the later, allowing for more seamless transmissions. 3GPP enrolls the ultra NR dual connectivity ENDC implementation as illustrated on figure. As you can see, we have both. As far core network is concerned, to the simulator provides the implementation of UPF module implementations for routing IP datagrams between G nodes, base station, and the data network. G nodes can be connected to the data network through the core network as shown in the figure left side. This architecture is also called the standalone deployment and is expected to occur in 5G only deployment. However, in the new few years, I tell you that 5G is deployed alongside the coexist the latter, allowing smoother transitions. To favor this, 3GPP defines ETRA, EUTRA, and our dual connectivity ENDC deployment shown in right side of the picture. Now we have modeling of NR protocol stacks. In simulator 5G, NICs are the compound which modules include one simple module per protocol. Of the NR stack, we describe the main modeling choices and functionalities of each sublayers. Now we have the sublayers for these. First we have PDCP layer. The NR PDCP module implements the PDCP protocol on the transmission path. It performs robust header compression and assigns, creates a connection identifier CID to packets. Their CID user ID is unique in the whole network. A logical connections identifier LCID is kept for each four tuple in the form source address, dest address, source port, dest port. A PDCP protocol data unit PDU is created and sent to the RLC layer below. And then we have RLC layer. In transparent parent mode TM, unexpected mode UM, and accounted mode NRLC can be enabled AM after modification. The TM does not have a buffer and transfer packets to the MAC layer transparently. AM and UM, on the other hand, have their own buffer system. While it before it MAC layer transparency has don't transfers, the TM don't have a buffer and transfer packets. On the other hand, we can see AM and UM have their own buffer system. RLC and PDUs are cached in transmission buffers and are fetched as a part of a MAC multi-axis edge axing communication programming procedure by the underlayer MAC module on Earth TTI. RLC PDUs are held on the receiving path until they have been reassembled, and this is forward to the PDCP. And RLC PDUs are saved in their receiving buffers. Now, after RLC, we have MAC layer, and in MAC layer, NR network radio framework is 10 millisecond long and consists of 10 subframes, each having a duration of 1 millisecond. NR subframes can be further divided into the variable number of time slots, which are called TTIs. A numerology index defines the slot durations, and accordingly, the number of TTIs per subframe UEs are scheduled in the slots and can support only a subset of available numerologies. The example in a figure shows a GNB supporting 3 CCS that implies different carrier frequency. You can see in figure shows that GNB supporting 3 CCS that employs different carrier frequencies and numerologies. The GNB serves UE1 and UE2. UE1 and UE2 which have different capabilities in terms of supported frequencies numerologies. For instance, UE1 only support U less than 3 and UE2 supports UE greater than 3. Frequencies below 6 GHz. According to the configuration, UE1 can be served by GNB using CC0 and CC1, whereas UE2 can serve by GNB, CC0 and CC can be used by CC0 and CC2. Now we have physical layer, PHY layer. At the physical layers, the effects of signal propagation interfaces on a whole MACTAB TB rather than on the symbols composing it are simulated. Each MAC TB is encapsulated with an airframe OMNET++ messages sent to the destination module. On receipt of the above message, the destination entity performs the computation summarized in the figure. You can see this figure. In this figure, the block diagrams of the modeling of the physical layer within simulator 5G, as you see, supports both FDD and TDD. In each can separate portion of spectra for the UL and the DL in the TDD. The same spectrum is used for both DL and UI, which are instead separated in time. NR allows one to choose among the possible slot formats, which are individual in a slot that can be DI, UL, or flexible for this slot formats. You can see payloads, TX format, frequency sources, TX, a channel mode, and different computer SINR, RX to channel mode, RX power, frequencies, resources to the binders, then list of interfaces to the SNR, and blur curves we have, blur curves is, and to the MAC receiver throughout the by this modeling of the physical layer of the simulator 5G. Modeling of device to device transitions. D2D communication is an LTE and NR capabilities that allows two UEs to user to interact directly when they are in close proximity. D2D transformation become quicker and when a single hop known as the side link SL replaces two. This allows a proximity service such as IoT broadcast, cellular vehicle to everything communication, CV2X. Data is transmitted on the SL side link in network controlled D2D, but the base station retains control over resource allocation. The follow direction of P2P follows can be either set static via the net INI file or change dynamically via some mode situation policies. In fact, the mobile UEs may not always be in communication range. Hence, the G node base stations may want to change their communication mode dynamically. In simulator 5G, the mode switching policies are user definable and can be used to switch between modes. Selection of flow of at PDCP layer, we can see the flow directions at the figure, both UE and GNB PDCP layer. We have it shows scheduling procedure which takes an input from IP to NIC to the IP datagram, where we have a SRC dataset IP address port. It gives the get flow information and IP datagram, that's the ID, LCID, flow directory I tell you before the previous. PDCP layer. That get flow information, we have destination ID, LC ID, flow director, IP data, and that we get the PDCP PDU RLC SDU to the RLC layer. Flow directions. H-ARQ high architecture mechanism of P2D and D2D, device to device communication. We can see the G NB G node base station to make PDUI and corrupt it as starting from transmitted power at the sender. It applies to channel mode to compute the received power. Channel mode can be configured to incomplete feeding, shadowing, path loss. We can see to the user, to the RX user, TX transmitter, receiver user data through the GN database. Modeling for scalability and simulating more cells implies a high computation load which limits the scale of scenario that can be simulated to solve issues. Synergy includes also two models G and B which can be modeled as a light cell. Light cell does not run the NR protocol stack. It configured with a location, radiation pattern, a transmission power and a distribution power of a occupied RPS on each TTI. It samples the value from the distribution and occupies the resulting number of RBs in the DL sum frame. The allow one procedure of configurable level of interface in the cell of interest without incurring the overhead of simulating many full stacks G node base station and their served users. And validations and calibrations. A simulator should be properly validated to ensure the results obtaining with are incredible. The techniques used to do several and should be used concurrently. Some of the ones are used with the simulator 5Gs are extensive parsing of event traces, leveraging the features of OMNET++, ID, continuity, consistency, and decorency tests, backward compliances, for instance, running a 5G scenario with FDDD, U metric equal to 0, IT, for example, TTI is for 1 millisecond as LT, forcing all nodes to use MC scheme, which are common both to LTE and NR network, yields the same result as simulator LTE does. Fingerprinting to test the results or the sequence of the function call does not change following code updates. Now we have 3GPP, urban macro and simulation scenario. Measured urban macro simulation scenario and measured SINR with simulator 5G. So you see the macro simulation scenario we here created in the figure, that are different network base stations are here through the one, and it can be seen that given to the different channels path of their transmitted to different data, and here we have the measured SINR 3GPP references. This shows that the 3GPP references are are here. Average error rate after first transition attempt. Oh, in this we can see in figure, we simulate the deployed according to a rectangular hexagonal demonstration whose intercept distance is 500 meter. Each side hosts 3 cells reading outwards according to the horizontal and vertical pattern described. We collect the statics only for the central size 3 central cells where the other light cells only produce interference upcoming. The randomly deploy 30 users in 3 center hexagonal, which the best SNR 80% of users are assumed in 20% outdoor. We assume the DL traffic and user receive the 240 kilobytes. Second is constant bit rate traffic. The value in following charts are obtained averaging the independent repetitions and confidence intervals. The main simulation parameters can be summarized. Shows that the CDF of SINR measure using the scenario in 3 GPP macro solutions. After we have average error rate after first transfer TX attempt and CDF error rate first we have the first transition attempt of transport blocks. The probability that first transmission of Mac transport block is not encoded correctly, the employed shift increase left to right. We observe the rate is close to target 10% error when a shift of either delta are used for CDF. Our error rate has the first H-ARQ transmission attempt where we observe that the target 10% error rate is around the median value, whereas only a small fraction of users gets an error rate larger than 20% where delta equal to 5 decibel or 7 decibel from the average error rate throughout the CDF. Now we have applications of offloading with Mac. Mac will be unleashed. It is full potential in combination cellular connection, A5G in Mac environment. Computer nodes known as MecHost are located near the RAN and directly closely with it. Mac applications execute virtualized environment on MecHost on behalf of users. Computation resources can locate it to consume who request a service or a job on demand. Simulator 5G offers some models of information structure as well as functionality that enable users to dynamically reserve requests, the initiation and the termination of one or more services. Mac and 5G. What next for the next generation of cellular network? Back to the page we come that according to the ETSI structure, Mac functions are organized in two layers. The Mac systems levels maintain a global view of the status of the Mac host in the system. The main building block of our model is MecHost, which hosts Mac application created on demand. The above architectures so users to develop its own Mac app and plug it seamlessly with Simulator 5G. This we can see the Mac host to communicate with the application that specific that is accomplished the above this architecture a user to develop its own Mac applications with seamlessly Simulator 5G. Mac platform we have service 1 service 2 to the application 1 application 2 and application. This is a visualization infrastructure which we have as virtualization manager and resource manager, and we have the protocols UDP, IP, PP and GTP we get in this modeling of Mac host module. Simulation scenario of ME app migration. ME app migration. We considered the scenario where five servers we have representing the Mac host are respectively co-located with 5G nodes base station. The inter-G node base station distance is 500 meter. One user is literally moving from the scenario of area of G nodes to the G node base station 2, G node base station 3, G node base station 4, G node base station 5. From the services area of G node 1 to the G node 2, G node 3 and so on at constant speed of 30 km per hour. The user interface offloads the tasks to MecHost predictably with period t is 1 second. For each offloaded task, user transfers the context to an Mac app running on the Mac host, which performs computations and sends the context back to the users. Be the context sized, hence the packets are transferred in measured in kilobytes. Moreover, we model the processing the time at the Mac host. We see the processing time at Mac host is are the cycles bit necessaries for processing times and frequencies processing capacity of MecHost between the one node station to another node station. Now we have of latency of task offloading, where we take I u is equal to 0. No migrations. With migrations, latency time comparing required for obtaining the result of task offloading over time. The users perform the handover at 64 second, 124 second, 184 second, and 224 second, with the latency increase due to the need of rerouting traffic through the UPF. With out service migration, see the latency increase due to the rerouting traffic signal. Where we see latency of task offloading UE, see that without service migration, latency always stays above 35 milliseconds. When the application migrates, latency goes back about 20 milliseconds after the transient. Shows metric where shows same to the latency of task offloading u is equals to 0. It is the metric where we implied 3 is implied it, and expected the latency has the same evaluation expect for scaled down values due to the shorter TTIs. Now platooning with CV2X. With the development of 5G and NR standard involves CV2X to support ultra reliable ultra low latency service for vehicle application like autonomous driving, platooning, infotainment, and so on. V2V connections can be either P2P or P2MP. Simulator 5G can be easily integrated with OMNET's vehicular mobility libraries such as VINS and Artery. We report an example of performance study of CV2X application with Simulator 5G focus on the platooning using use case in which vehicles are told to proceed in a train-like way, for example at the same speed with a short constant and distance to the vehicle ahead. The platoon leader PL is the first vehicle followed by the platoon members. We can see by this CV2X platoon. Simulation scenario we can see in this where the 3G node base stations are connected to a single MAC host in the core network. 5 vehicles are moving along the road are required with the NR NIC so that they can exploit 5G connectivity. The service offered by the MAC host to a form of platoon. In particular, the first vehicle is the platoon leader, whereas another are the platoon members. At the beginning of the simulation, vehicle have different speeds, distance from their respective procedure. Each vehicle runs one application that sends the information about the vehicle position, speed, which is spent to Mac application at the Mac host every meantime. Mac host consecutivity shows every running period of Mac services, platoon formation services. The group vehicles it platoons based on formations gathered Mac applications and a platoon control services that takes as input and formed by the PFS and computes new acceleration values that vehicles must use in order to coverage towards the target. Vehicle distance from their procedure over time vehicle and speed over time. While moving vehicles perform handover to G node restriction, they receive highest SINR, which since the distance between G and ABS is 500 meter and vehicle's target speed is 5 km per hour. Vehicle remains in the area covered by the G nodes. During the simulated time, we compare two different strategies to deliver PCS command. The first mode in gets acceleration value via DL transmission is serving shows. In the second figure, we can see that mode of one message including the acceleration of all vehicles is sent to the PL with the transmission forwards the message or to its follows transmission to using PM1 using a T2D transmission which in turn relays into PM2. So on this nothing that T2D modeling allows P2P and P2P connection between them. Now we have a conclusion here that Simulator 5G, a new model library for 5G NR OMNET simulation framework, was introduced in this report. In this paper we get, to our knowledge, this one of the two libraries that suppose end-to-end application level communication in complex diverse scenario, that other being 5G, uh, but it's only the one mod that models in ENDC installations, FDD access, DT2 communication, MAC and CV2X. We have explained simulator 5 resource, 5G resources, managements and protocol layers to help prospective user understand its modeling and methodology, which is geared at the 5G services and resources management researches. We submit the validation findings. We find the validation finding demonstrated near perfect conformity with 3GPP criteria. We find that the simulator 5G may be used to access cutting edge research technologies such as MAC, PLATOONING with CV2X with minimum setup work on the user part. We have the future work here. Future work on this topic, we involved a detailed investigation of simulator 5G's capabilities as a real-time simulator. Some first findings from the line of studies have been given in and suggest the simulator 5G may be used application programmers to test their application and services in a controlled yet lifelike environments, perhaps in conjugation with rapid prototyping tools such as an Intel OpenNAS framework for MecHosting, with which simulator 5G is perfectly integrated. Thank you. This is all from my video. Thank you so much.